Here in 15.3, we're going to look at the range, also what's called the interquartile range, and then standard deviation. So the range we're pretty familiar with. What's the difference between the maximum number and the minimum number? So how much range does our data cover? What's the difference between the high and the low? There's another type of range they'll talk about called the interquartile range. So like we saw on the box plot, between the 25th percentile and the 75th percentile is the middle 50% of data. And so all they're doing is giving that a name. If I'm looking at a box plot, could be any kind of shape, right? This is Q1, the 25th percentile. This is Q3, the 75th percentile. That means half the data is between here and here. So they just give that a name and they call it IQR, the interquartile range. So how far is it from here to here? Whereas the range, without the interquartile part, is what's the difference between the max number and the minimum number. So here's one 2007 SAT math scores. The minimum was 200. So apparently you can, if you don't get any questions, you can get a 200. So if someone didn't have any questions, right? So the minimum, then Q1 was 430, the median was 590, the maximum was 800. And let's see. Do they tell us Q3? Oh, I think they meant this to be Q3. I think there's a little typo in the PowerPoint here, because they just use that for that. Alright, so let's say that's Q3. So let's make a box plot just so we can kind of see it. So if the low score is 200, Q1 is 430, Q3 is 590, and the maximum score is 800. I think they didn't tell you the median in this one, just because you don't need it for range or interquartile range. Okay, so what's our range? Well, from here to here, the highest to the lowest score, it looks to be between 800 and 200, so our range is 600, 800 minus 200. So how far is it from one point to the other? And then our interquartile range is from here to here. Where's my middle 50% of values? So 590 minus 430, it looks like our interquartile range is 160. So this number minus this number. So it's just how far is it from there to there, how far is it from the 25th to the 75th percentile, whereas the middle half of scores fall between a range of 160. Okay, so then the second part of this section is standard deviation. And what standard deviation is trying to do is give you an idea of how spread out the data is. Do you have a test where the average was 70 because everybody got close to a 70? Or did you have a test where some people did really poorly and some people did really well and so the average was 90? So are all the scores bunched together or are they spread out? And when you get to the homework, you won't have very big data sets because it's a little tedious to do by hand, so I think they keep them like 5 and 10 number data sets or smaller, so you won't have to do very many of these by hand. Or at least you won't have to do very many numbers. Okay, so picture if we had a data set where all the numbers were the same, then the standard deviation would be 0, meaning there's no deviation, they're not spread out at all. Alright, so let's look at an actual data set, and here they're telling you how do we actually compute this. So first you find the average, then you decide each of your data points, you do the data point minus the average, basically how far from the average is each point, and then you square all those, and you take the average of that, and then that's called the variance, and the standard deviation is the square root of the variance. So we'll see one. It ends up being, it's not like a long formula, it ends up being a multi-step kind of process, where you can't do the whole thing all at once. Okay, so here's one. We have 10 grades on assignments. An 85, an 86, 87, 88, 89, 91, 92, 93, 94, 95. Alright, so first thing we need is her average. So add them all up and divide by 10. So it looks like the average is 90. And so knowing that the average is 90, for every single data point we'll go and say her score minus the average. So this one was 5 points below the average. This one is 86 minus 90, so 4 points below the average, 3 points below, 2 points below, 1 point below. This is 1 above the average, 2 above, 3 above, 4 above, and 5 above. And then they square them all, honestly, because when you take the average here, when you add them up, you don't want the negative ones and the positive ones canceling off. So if we square them all, we end up with only positive values. So negative 5 times negative 5 is positive 25. 4 squared, 3 squared, 2 squared, 1 times 1, 1 times 1, 2 squared, 3 squared. And so then I need the average of this whole column. So if we add these all up and divide by 10, and so we can leave it till we'll take their word for it. Well, it's like 50, 32, plus 18, another 40. So it must add to 110. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So the average of this column is 11. And so then what that's telling you is that your variance is 11. If you want the standard deviation, which they use this little sigma symbol for very often, if you want the standard deviation, you have to take the square root of this. And so the square root of 11 is about 3.3. And so picture what this saying is on average, her scores are about 3.3 away from the median. So some of them were 5 below or 5 above, and some of them were closer. So on average, the scores were about 3.3 away from the middle. So that's how you find standard deviation. How far from the average? Square them, average those numbers. That gives you variance, and you take the square root to get the standard deviation. And if you want to use this little sigma symbol, you can, the Greek letter, or you can just write standard deviation. I like abbreviations. Just be careful if you do this, it starts to look like a 6. So sometimes you got to make sure that like the top part of it, you make like really flat or something like that. If you've seen that kind of popular business book model called Sigma 6, Six Sigma, there's something more about statistics in that, but that's what they're talking about is this. It's if you're within 3 standard deviations of the mean in either direction, so that's where that name comes from. Oops. So some things to think about the standard deviation. So she was pretty consistent. She was close by 90. Some were 5 above, some were 5 below. So a small standard deviation tells us that they're not very spread out. So the ultimate consistency, so what if she got the same score on every single assignment, then the standard deviation would be 0, because there's no spread in the data. So let's say another student, let's say they get a 5, a 15, a 25, a 35, a 45, a 55, all the way up to 95. So they got some really low scores and some really high scores. The standard deviation in this one is 29 points, or almost 29 points. And so you notice the one we did was 3.3. So this is data that's much more spread out than our data. And so that's what standard deviation is measuring, is how far spread out your data is. So measured in the same unit, so if those were test points, it's still in test points. Let's say if the standard deviation was dollars, then it's, $5 is the standard deviation, or salaries, so it's in the same thing. It's pointless to compare standard deviations of data sets that are given in different units. So if we're talking inches to inches, feet to feet, dollars to dollars, they have to have the same scale or it doesn't make sense. So we shouldn't try to compare the standard deviation of her SAT scores, because SAT scores, first the lowest you can get is 200 and the highest you can get is 800. We shouldn't compare that to homework where you can get between 0 and 100s. They'd have to be on the same scale for it to even make sense. So say like if I have a quiz where the lowest you can get is 0 and the highest you can get is 10 versus a test where you could get 0 to 100, those standard deviations will already be different because the spread on the points you can get is different to begin with. So they have to be the same scale and the same units to be able to compare standard deviation. But if they have the same units and the same scale, they can tell us something. So a small standard deviation is that the values are closer together, and a large standard deviation means that They're more spread out. And so the more spread out they are, the larger the standard deviation. Kind of like the one we're probably most used to is like on a test, maybe 70 should be about the average. So it'd be a very big difference if you have a class where everybody gets about a 70, so the average is a 70, would be a small standard deviation. You could have another class where a bunch of people get 100, a bunch of people get a 0. And so you could still end up with an average at 70, but that's very differently spread out data. You have high scores and low scores versus everybody around the same score.